So hey guys, welcome to Chemistry of Carbon channel. This is Abhinav here and you're watching another video of Chemistry of Carbon. Now, let's just look at the nomenclature of organic compounds, and this will be focusing more on the IUPAC naming of organic compounds. We'll just look at a very brief idea on how do we give the common names, but mainly on IUPAC nomenclature. I know we're not live today, but yeah. So let's just start with the word root or compound roots as we call them. Now, so whenever we have to give name to a compound, we generally pick the number of carbon atoms and then we decide the word root for it. This essentially is the most important part of nomenclature of organic compounds, and for one carbon atom, we use meth. For two, we use eth. For three, prop. Four, bute. Five, pent. Six, hex, and so on. Now, the thing about, well, whatever we have written, methane, ethane, propane, butane, these are all alkanes, so we add the suffix ane. Now, if we have to add a substituent, that is like CH3, CH3, CH2, CH3, CH2, CH2, like that, we would just remove the A and E and add a YL. Yes, we would. So all these substituents, as we mentioned earlier, the alkyl group is just an alkane. If you remove a hydrogen, we get alkyl. Now, let's look at the IUPAC format of giving the names to compounds. So, whenever we name a compound in organic chemistry, we use this template here. So, here we have the prefix, which tells us about the substituents or the shape of the compound. And then we have the compound root or the word root and the suffix. Now, first, whenever we name a compound, we have the secondary prefix, which tells us about the substituents like the alkyl group, nitro, halogens, etc. Then we have the primary prefix, which tells us about the shape. Like if we have a straight chain, we usually use N and then whatever we have to write like alkane, like butane, pentane, etc. Now, if it's a ring, if it's in the form of a ring, then we use cyclo. We'll be looking at only these two now, but yes, we do have other prefixes like spiro and bicyclo. Now, the word root given here, or the compound root, is just the number of carbon atoms in the parent chain, like we saw in the previous slide. So we have meth, eth, prop, and so on. Now this unsaturation index is just the bonds present in it. Example, for all single bonds we have ane, we have double bonds we have ene, for triple bonds we have ine. Now the last one is a functional group. Now the functional group and some substituents are actually related to the priority order, which we'll see later. Now in this, the functional group, we add a suffix. Example here, for alcohol we add OL, for aldehydes we add AL, and for carboxylic acids we add oic acid. Now let's just look at the rules for nomenclature of simple hydrocarbons. Now simple here means that it's a saturated hydrocarbon and it does not have any functional group, and the only substituent here is a methyl or ethyl, an alkyl group in general. So we have five rules actually. The first rule is we have to determine the longest carbon chain in the molecule, which is known as the parent chain. We discussed this even in chain isomerism. Yes. So where a double or triple bond is present, choose a chain which includes these bonds. And if there's a cyclic structure present, the longest chain starts and stops within the cyclic structure. So we have a normal chain. Then we would choose this as the chain, and this is the substituent, not any other way. And if we had to give, if we had a cyclic structure and we had a substituent like this, then this would be the chain. It would be cyclobutane in this case. It will be methyl cyclobutane. And in case we had a double bond or triple bond, let's say we had a chain like this, we would name this would be the chain. Okay, this would be the chain. So this thing, naming it like this, is wrong. I'm just color coding it now, and this is right. Now we have to assign numbers to each carbon of the parent chain. Numbering is done to identify the parent alkane and to locate the position of the carbon atoms at which branching takes place. Now, parent alkane could be alkene or alkyne also. This is just because generally we usually have alkanes. Alkenes and alkynes are not as common as alkanes. So the numbering is done in such a way that the branched atoms get the lowest possible number. Now, the rule 1 is also known as the longest chain rule, and rule 2, as we sometimes call it, is the lowest locant rule. Now, let's look at the lowest locant rule with a diagram. So, let's say we have carbons like this. Now, even the hydrogens are there, but just that we're trying to say that the hydrogens imply. Now, let's say we have a methyl group here. Now we could number it in this way, or we could number it this way. And remember, all these numbers are for this chain or for this chain, because in the end, they'd be it would give the substituent the same number. Now we would take the one such that the substituent gets the lowest number. So that means we would take this and this would be wrong. So the name of this compound, we will just discuss it in steps for now. Now we have to determine the compound root and the unsaturation index. The compound root corresponds to the number of carbon atoms in parent chain. So we have to add prefix cyclo if the parent chain is cyclic. So if it's cyclic, we just add cyclo. Now this was our chain. So then we would just see the unsaturation index or just check if the bonds are single, double, or triple. So it's single, so it would be A and E. Now let's say we have to find the compound root. We saw that it would be 4 carbon atoms. Yes. So then it would be but. If it was any other number, it may vary. So the compound root corresponds to the number of carbon atoms in the parent chain. Yes. Now we have to determine the correct name for each branch. For example, alkyl groups such as methyl, ethyl, etc. So now it will be CH3. So this is methyl. C2H5 will be ethyl. C3H7 will be propyl, and so on. You have to attach the name of the branches alphabetically along with their positions to the parent chain as prefix. Prefix. All these substituents we'll put as the prefix. And in this case, we'll not have it alphabetically because we just have methyl. If we had ethyl, propyl, and so on, we would have alphabetical order. So we would give more priority to the one which comes alphabetically first also. Now we have to separate numbers from letters with hyphens. Now let's see how would we name this compound here. So we would just name this as butane, just normal butane, and this is at number 2 like we saw earlier, 1, 2, 3, 4. So it would be, just write it here, 2-methyl so it would just be 2-methyl butane. This is just 2-methyl butane. Yes. Now that this is the last rule for simple hydrocarbons. So when two or more branches are identical, we use prefixes di, tri, tetra, etc. Numbers are separated with commas and prefixes are ignored while determining alphabetical order. That is, these prefixes to show number are ignored. Now we did this kind of an example. So this would just be 2-methyl propane. Now let's look at this example. This we'll look at maybe a little later because we've not yet done the bond line formula. So this, how would we number this? Generally, we just number it like this. On first noticing it, and then maybe we would just instead go for this. But now we have to notice one thing here, a double bond. So this would get the first priority, and then we have the longest chain rule. So based on that, it would just be 6. So the word root would be hexane. Hex, it need not be in, right? It will be in. And if you want, we can just show the number as 1, but as per IUPAC nomenclature, we can even omit the 1. Hex 1ene. And then, so we have ethyl here at place 2. So it will be 2-ethyl. And then at 4, we have 2-methyl. So we'll use this prefix di. So we would just write it like this. 2-ethyl 4,4 dimethyl hexene, hex 1ene or hexene. Now the same way we would have to do it for this. We would just tell you the numbering is like this. And then we would use ine here. It would be pent 2 ine. And now we have at place 4 the methyl. So we would just we would just write it as 4-methyl pentoine. And in fact, these two are very similar except that there's no double bond, it's all single bonds. So we would have to use the rule that ethyl would get more priority because of the alphabetical order. E comes before M. Now, we looked at a part of IUPAC nomenclature. Now, let's just see how we give the common names. Now, the same in the same fashion as we have IUPAC nomenclature has the word root, even common names generally have a word root, and it is that we have for one carbon atom we use foam, for two we use acet, three propion, four butyr, and five valor. Now there is one more thing here, like let's say we have C2H5OH, which is ethanol as per IUPAC nomenclature, but the thing about common names is that we know that this part is just a ethyl, and this is an alcohol. So the name is ethyl alcohol. And let's say we have CH3, C double bonded with O. This is a ketone group as we saw in the previous session. Now, for this and this, we would use acet. And the thing is, this has a ketone, so it's acetone, O-N-E. So the name of this compound is acetone, A-C-E-T-O-N-E. Now let's look at some corollaries. So if there happens to be two chains of equal length, then that chain is selected which contains a greater number of side chains. And then now we look at cyclic compounds. So if we have, let's say we have a ring structure here, then a ring will only be treated as a substituent when the number of carbon atoms are less in the ring than in the chain. So let's say we have a ring here. This is cyclobutane, and it's attached to another this chain which has 5 carbon atoms. Then this will be the longest chain and will be the parent chain, and this will just be taken as a substituent. Now there's one more thing, that if we have a cyclic chain, a cyclic ring, and it's attached to a carbon atom which has a double bond, even though it has lesser carbon atoms, this will be the parent chain because it has a double bond. Double bond has more priority. Now, let's look at the chain selection rules for alkene and alkyne priority. That's double and triple bonds. So, we select the chains which contain maximum number of double and triple bonds. So, if two chains are competing for selection as the chain with maximum number of unsaturated bonds, then the choice goes to the one with the greatest number of carbon atoms first. This is just the longest chain rule. And the second is the number of carbon atoms being equal. If the number of carbon atoms are being equal, then the one containing the maximum number of double bonds. Or if they're only triple, then triple bonds. But if they're equal double and triple bonds into different chains, we would take the one with double because double has more priority. Now, we looked at these functional groups earlier. So this is just the hetero atom present in them. In aldehyde also we have oxygen. In ketone, we have oxygen. Carboxylic acid, we have oxygen. Now, how do we name them? Now, this is for halogens, we just, let's say we have chlorine. We just write chloro, bromine, bromo, iodine, iodo. And then we write the name of and then we just write the compound. Like, let's say we have an alkane, like with 4 carbons, we butane. So, chlorobutane. Now, the thing is, for halogens, we just write let's say we have the halogen is chlorine, then we just remove ine is removed, so we have to remove ine is removed, and we add o. For alcohol we just use the suffix "ol", and let's say we have an alkane, alkene, or alkyne. Now the thing is, we would just remove the E and add an O for OL, because as per IUPAC nomenclature, we cannot have two vowels together. We'll have to remove the vowel. So we'll remove the E from the alkane, alkene, or alkyne. Now, for aldehydes, we just use al as a suffix. And for halogens, we just use a prefix. It's always a substituent, that's why. For aldehyde, we use al, same way we have to remove an E. For ketone, is the same thing. So then for aldehyde, we just use al. For ketones, we just use one is a suffix. So then we remove the E. For carboxylic acids, we write oic acid as the suffix, and we remove the E again. Now, for the substituents, like we have some groups like alkoxy, nitro, and halogen groups. The thing is, these groups are always treated as substituents, always. Now, let's take the alcohol group here, CH3OH, and let's see the alkoxy group. That is, the alkoxy is basically ether. Nitro and halogen groups are just known like that. Now, the alkoxy group is ether. Now, CH3O is written as methoxy. CH3CH2O is ethoxy. CH3CH2CH2O is propoxy. And this is isopropoxy. This we look at a little later. So this compound, when we take it as a substituent, it will be at place 1, 2. This is carbon 2. So it will be 2-methoxy, and it's 1, 2, 3, 4, 5. This is a condensed formula, but all of them are single bonds, so it will be 2-methoxypentane. Now, complex substituents. Now, in this case, numbering is done separately on complex substituents, and number 1 is assigned to the carbon attached to the parent chain. In the sense, let's look at this example here. Now, in this example, we have, this is the complex substituent in the box. Now, this is number 1, and any of these can be number 2. Let's say this is number 2. So now the naming is a little different in complex substituents. So it'll be 1, 2, 3, 4, 5, 6, 7. So heptane. Now, this is at place 4. We write it in brackets always, complex substituents. Now this will be 1 comma 1 dimethyl dimethyl ethane. No, but ideally this itself is a substituent, so we write ethyl. Now this is the naming, so this will be ethyl and not ethane or ethene. Now what happens if we have, let's say, two of them, like in this case? First of all, don't be confused by these examples, because this part is just normal. It's just a normal substituent, because we can take this as a chain, right? And these two are just, it's just dimethyl. So this is not one of the cases. But yes, if there are two or three, we add bis, tris, tetrakis, not ditri-tetra. So not just because it should be convenient, there shouldn't be any confusion. Now, before we get into nomenclature of benzene derivatives, we'll just look at the bond line formula. Now, bond line formula is a shortcut method of just drawing the bonds and just showing the carbon atoms in the form of sticks. That's why it's also known as stick formula. And we say that the hydrogens imply. Let's take an example of ethane. We just draw ethane like this. We don't draw methane because methane is just CH4, it's easy to draw. This is ethane. And we always draw it slanting, because if we drew it straight, we wouldn't recognize that there were even, it's just a straight line, could just get confused. So ethane, ethene, we draw it like this. Ethyne, we draw it like this. Now let's look at propane, and butane is like this. Now for a double bond in propane, we just draw this. For triple bond, we just draw one more like this. Now as per this, benzene has two structures which you need to know. Benzene can be like this with the alternate single and double bonds, or this. Now benzene could be that what we drew earlier. It's alternate single double bonds. Or we could just draw a circle. We'll look at it in another session why we draw it so, but yes, this could be any of these two. Now let's look at the common names and IUPAC names of important compounds of benzene. So whenever we have any halogen, we just put the same way we used to write fluorine, we just add an O. Chlorine, we just add O, and then we just write benzene, and then we add, whenever we put NO2, this is a nitro group. What we saw earlier is always a prefix, a substituent, and we add it always as a prefix. This is nitrobenzene. This is acetophenone. Yes, because ideally there should have been one more CH3, but then it takes its place, benzene. And whenever benzene acts as a whenever benzene has C6H5, It's it is called phenyl. That's why phenol is just an alcohol. And benzene sulfonic acid is this sulfonic acid group attached like this. And we have CH3 attached to it as methyl benzene. Now this is also called toluene. And one more thing is, it's not mentioned here, is whenever we have benzene, we have CH3 here, and we have another CH3. This is called as xylene. And based on the places, we will define that a little later. This is methoxybenzene, or its common name is anisole. Whenever we have NH2, we name this as benzenamine or aniline. This is benzene carboxylic acid or benzoic acid. Now, with reference to a substituent, let's say X, we define three positions on the benzene ring as shown in the figure. Whenever it's just adjacent to it, we just call it as ortho. And whenever we need to mention ortho, we just put small o and a hyphen. And whenever it's just beside the ortho position, we call it meta. We put the small m and the hyphen. And just opposite to it is called para. We put a small p and a hyphen. This is always used in the common names. So whenever xylene has it in the ortho, we put orthoxylene, metaxylene, and paraxylene. So we saw it's called a phenyl group and it's C6H5. A saturated chain containing benzene ring is named as derivative of the larger structural unit. This corollary for longest chain selection of cyclic compounds. The chain is unsaturated, the compound is always named as a derivative of that chain. Now, this is like, you can just take a screenshot of this. This is the class formula, prefix, suffix, and the priority order. Now, here we have not mentioned the halogens. So the halogens will just have a prefix as halo, whatever it is, chloro, bromo, iodo. This this X here is just the halogens, and the R here mentioned here is the alkyl groups. That's methyl, ethyl, propyl, so on. Now, so we just have acid, halide. Now, the first one in the whole, all the lists, wherever there is two, the first one, like these ones, like some of these are actually names for benzene. So whenever there's a C in bracket, it means it's part of the chain. When it's not a part of the chain, then it's generally for benzene, or could be for cyclic compounds as well. We have another prefix and suffix. Now this is the priority order for polyfunctional chains. Polyfunctional just means that there are two or more functional groups. First is carboxylic acids, then sulfonic acids, then esters, then acid halide, then we have amides, then we have cyanides, aldehydes, ketones, alcohols, thiols, amines, double bonds, triple bonds. Yes, these are only some. There's a huge list. Now, let's just practice some questions. Now we have the condensed formula here. Now this just means that two CH3 units are attached to this. And most people think it's in the bracket, so complex substituents. So this just means to say that they are substituents, and they just put it. That's not the correct thing. Let's just say we have CH2, CH, and then we have this double bond CH. We would put CH3 here and a CH3 here. Now this will be 1, 2, 3, 4. Why is it like that? Because even if you put it 2, we'll get double bond 2. If you put it from here, it'll be 2, but the substituents should get lower number. So 2 here, if we go like this, it will be 3. So what will be the name of this compound? It will be, well, it will be 2-methyl butene. Butene, butene. Yes, this is the answer. And now one more thing is that this is the thing that it's actually a pretty famous medicine question. Now let's look at this one. The IUPAC name or names of the following compound is or are. Now we see that this is benzene. Now this depends on how we define this compound. Now let's say we take this part as one and name it as toluene. We use toluene in the IUPAC name, so it will be toluene. So respect to this, we could use P para chlor, but that's the common name, so we would use just 4 chlorotoluene. So this is right. So B is right. Now we can see that chlorine and the methyl group, we could treat them separately. So chlorine would have more priority, 4. So we would have one chloro. We would have one chloro. One chloro. 4-methyl. 4-methyl. Because we started 4. And the last thing is it's just a benzene. So option A and B. Option A and option B are right. It's not any of these. These are wrong. Now this is the beauty of this question. Now let's just look at this question. Now we have a pentane here, or we could just take this as a chain. It would remain the same thing. So this would be 1, 2, 3, 4, 5. Because it's symmetrical, we could just do it in any way. So it would be 3. What is this? This is non-methyl. This is 1, 2, 3, 4, 5. C2H5. So this is 3-ethyl pent, and they're all single bonds, so in 3-ethyl pentane. Now let's look at this. Now this is this the IUPAC name of this. We would give 1, 2, 3, 4, 5, 6. Because it's symmetrical, we could just do it in any way. So this is a ketone. This is a cyclohex 2,5e cyclohex 2,5 diene diene 1 on DIEN 1 on. And what is this? 3,4,4,5 3 4 comma 4 comma 5 tetramethyl, because tetra is for 4, tetramethyl cyclohex 2 comma 5 diene 1 on, because this is ketone here. Now the thing is, its common name is just penguinone. Penguinone. This is beauty of organic chemistry. Sometimes we just see the IUPAC name is so easy. Sometimes the common name is so interesting. So thank you guys. Hope you guys enjoyed the video. If you did like the video, do hit that like button, subscribe to the channel, and share it with your friends and family so that they can be benefited from it. And do put your comments in the comment box below. Thank you.